Students, through our previous video you have learned about various operations of set. They are intersections of two or more sets, then union of two or more sets, then which is called overlapping set. What are disjoint sets, then how will you find out the difference of two sets, then complement of two sets, and etc. Few of the laws are there in set theory as well. Laws you have learned for addition and multiplication, especially all those commutative law, associative law, distributive law, means for other operations of math like addition, subtraction, multiplication and division. All the laws, a few of the laws are there, and then you have got two extra laws there, idempotent law and that De Morgan's law. These two laws especially we will see, and other laws also how they work in set theory, that we will know. Okay, fine. I move on to idempotent law. It says to you two set. If suppose set A union with set A, it means union is what? If a set is union with itself, that will be the set itself, isn't it? Suppose I will give an example. Suppose set A is 1 and 2, element with 1 and 2. Again, if you are union with one a set which is having 1 and 2 as element, and another set again 1 and 2 as element, then union will be both, because the element cannot be repeated. So 1 and 2 will be the union set. So union of a set with itself will be the set itself. That's the first formula. That is idempotent law, first formula. Similarly, any set intersection with itself will become the set, same set. Now, a set is union with empty set, and a set is intersection with empty set. That time what will be? A set is union with empty set will be the set itself, but when it is intersecting with empty set, it will become the empty set. That is what the law says. And it is fact also. Take the example, you will be understanding later. See, A is a set, union with empty set will be a set only. Say suppose a set A is having the element as 1 and 2 and intersecting with 5, then definitely a union with 5, then definitely set A's element will be the new set. That is what. But if you are intersecting means common element, set A's all the element will be part, means 5 will be the part of that set A's element. I said so the subset of set A will be first subset will be 5 of any set. So intersection of a set with empty set will be 5, but union of a set with empty set will be always the set itself. Remember all these things. Now commutative law, do you remember when commutative law of addition was what? I will give an example. 3 plus 5 can be written as 5 plus 3, isn't it? That is a commutative law of addition. Similarly, here also A union with B will become B union with A, isn't it? A intersection with B will become B intersection with A. That is a commutative law. Associative law is what? Associative law means A plus B within a bracket sum of A plus B added to C will become sum, A plus sum of B plus C. That is what the associative law of addition. Similarly, here also associative law will be A union B union with C. A union B is a set. That if you are making union with the set C, that will become A union B union C. B union C is a set B union C. You understand? Now, similarly, A intersection B together, A intersection B is a set and C is a set, intersection part will become A intersection B intersection C. Could you understand? Now, distributive law, try to understand distributive law. You remember the distributive law you have learned for multiplication. A into within bracket B plus C. What will be? AB plus AC, isn't it? Similarly, here also A union B plus C will become A union B intersection A union C. A union B intersection A union C. Similarly, A intersection B union intersection A intersecting B union C, what will happen? B intersection A intersection B union A intersection C. Understood? Go through slowly, you will understand. Means you are distributing this one with this, you are distributing this one with this. This whole you are distributing with this, that will, this sign will remain unchanged. Then this whole you are distributing with this. You understand? Now De Morgan's law is very, very important for set. This is a new, this is not as like addition, subtraction and all the other operations. See, De Morgan's law is A union B complement will be A complement intersection B complement reverse. A union B complement. Think with the Venn diagram, draw two sets. Then A union B complement, total complement will be the element remaining in the universal set. So that one is take, and then A complement you find out there, B minus A part will be included, and then other part will be there, what is that, outside A union B part. That will be, if you take it to the Venn diagram, it will be more easy. So A union B complement will be A complement intersection B complement. Conversely, A intersection B complement will be A union B complement will be, A intersection B complement will be A complement union B complement. Go through the law, you will understand. I will take some exercise some of the sums. I have taken from question number 2, exercise 2A, two sums I have taken, question number 1 and 3, 1 and 2. By this you will have a clear conception. See, question number 1 is given to you. If say A is a set having the element 3, 4, 5 and B is a set having the element 5, 6, 7, 8. Now you need to find out what A union B. You are very, very simple, very, very simple. These two sets are given to you. These are the elements of these two sets. A union B will be what? Union is together. All the element together, but you can't repeat the element. So without repeating the element, one time all the element together. So A union B will be what? A union B will be what? 3, 4, 5, 6, 7, 8. 5 is common in both. 5 you cannot repeat. So 3, 4, 5. One time only 5. 6, 7, 8. Together this element and this element together you will combine, but without repeating the element. 5 is repeating, so giving 5 all the element together will be A union B. Now A intersection will be what? Intersection means common element present in the sets, in both the sets. So A set and B set is common element is what? 5 is the common, very obvious, it is 5. So A intersection B will be only 5, nothing else. No, A intersection B is 5 only, singleton set. So this is the answer. Now moving on to A minus B. I have said in previous video, A minus B or B minus A, element present in the first set, not present in the second set, element present in the minute set, which is not present in subtrahend set. So element of set 3, 4, 5 is present. Out of this element which is not present here, that will be A minus B. So 3 and 4 is not present here. You see 5 is present here, so 5 will not be. So 3 and 4 will be A minus B. So A minus B, 3 and 4. You understand? B minus A, similarly, B minus A will be what? Element present in B, not present in A. So element present in B, what are the elements which is not the part of A? See, 6, 7, 8 is not present in A. Therefore B minus A will be 6, 7, 8. Hope you have understood that. What do you need to verify? Further you have to do something now. This question is asking you to verify what? Based on this, you have taken out some of the values. Now see, what you need to do, first verification is A union B is equal to B union A. So, that is which law? That is commutative law, isn't it? But you can't quote the law and do it. You have to find out, you have to do the operation and come to the conclusion that A union B is equal to B union A. That is what we will do. A union B is equal to B union A. So see, A union B, you know, you have already taken the value. This is the set. These are the element. B union A you take out. B union A you take out. B union A once again. You just combine all the element of both the sets. That was without repeating. You will find again 5, 6, 7, 8, 3, 4. 5 will not be. So B union A will be 5, 6, 7, 8, 3 and 4. And A union B is also same 5, 6, 7, 8, 3 and 4. Are they not same? This set and this set, are they not same? They are same. And C, B union A will be, these two are equal. Therefore, A union B is equal to B union A. Proved or verified. Do you understand? Now moving on to B part. B is set to B intersection A. B intersection A. See what will we do for B? A intersection B is equal to B intersection A. Again, the commutative law. What will you do? See, B intersection A just is what? You see, B intersection A. Element present, commonly present in both will be 5. B intersection A is 5. Okay. Now, A intersection B is what? If you find out these two, again it is 5. Isn't it? So, this is 5. Therefore, A intersection B is equal to B intersection A proved. Now, moving on to C. C is asked to you A union A is equal to A. Any set union itself will be the set itself. That is, I don't put in law. We have learned it. We can find out. Now, we can prove it. A union A. Write down set A. 3, 4, 5. Again, union sign give. Again, you write down the element. So this 3, 4, 5 within curly bracket, union with 3, 4, 5 within curly bracket. If you are uniting these two, 3, 4, 5 with 3, 4, 5, without repeating the element, what will happen? Only 3, 4, 5, 3, 4, 5, which is the set A. Therefore, 3, 4, 5 union 3, 4, 5 is equal to 3, 4, 5. Thus, is equal to A because this is equal to A. That is verified. Now, A union empty set 5 is equal to what? If you are uniting, empty set is having C, write down A's element, then 5 element without putting any element, you write down symbolically 5 within curly bracket. So 3, 4, 5 union curly bracket empty. Then what will happen? This two if you are uniting, then this will be the 3, 4, 5 only will be. So 3, 4, 5 is the set which is equal to set A because set A is having this. Now D is A and E is A union A is equal to what? You have to prove A union intersection A is equal to A. Any set is intersecting with itself will become the set itself. Intersect, prove it. A set element you write down, intersection sign you put. Once again write down the A sets element. Then these two sets common element are what? Common element is all the element. So that is what you have put, and this all the element is the set itself, that is A verified. Now last one, A intersection null set. A sets intersection null set. Intersection part is there, you will find the null set only is a null set. So any set is intersecting with null set will be null set. Any set is union with null set will be the set itself. That is what you come to a conclusion. Moving on to question number 2. It is very simple. You need to find out sets and then proof is very simple. See, universal set is given to you. Here you are trying to find out complement sets. Not complement set and different set, difference of two sets. See, universal sets. Complement when you are finding out, no, that time always universal set is a matter. Universal set has to be there. So here universal set is given to you. P set is given to you, Q set is given to you, R set is given to you. Under this universal set, there are 3 subsets P, Q and R. Now P complement will be what? P complement will be the leaving the P sets element, which all element are there in universal set. Leaving the member of the set itself, which all are present in the mother set, that is universal set, that is the complement. So P complement will be leaving 5, 6, 7, 8 as an element, 5, 6, 7, 8 will leave it, 9 and 10. P complement will be, no, 9 is there, 8 and 10. It will be 8 and 10. That is the answer. Q complement leaving the element of Q. Q is having 5, 6, 10. 5, 6 and 10 you just Don't take 7, 8, 9. 7, 8, 9 will be the answer. Now R complement 5 and 9 you need from here, 5 and 9 you need from here. So you get 6, 7, 8 and 10. 6, 7, 8 and 10 is the answer. Now going to question number 4, P minus Q. I said to you, element present in P which is not present in Q. Which all member of P is not there in Q, that will be P minus Q. So which are P and Q, we just compare. P, what are the elements? 5, 6, 7, 8. And Q 5, 6. So 5, 6 is present in Q. So 5, 6 will not be. Then leaving 5, 6, what are the? 7 and 9. 7 and 9 will be minus Q. Now see Q union R. Q union R. These two set to consider. Union. Union means both the. So 5 will be written one time. 5, 6, 9 and 10. So Q union R will be 5, 6, 9 and 10. P intersection R. P intersection R. P and R, if you are intersecting, which are the common elements? 5 and 9. 5 and 9. P intersection R will be 5 and 9. Now P minus Q union R. Q union R we took it. Q union R we have already taken. This is the set. 5, 6, 9 and 10. That element present in P but which is not the part of this particular set. So present in P are this one. P are this one. 5, 6, 7. 5, 6, 7 and 9. And but here it is 5, 6, 9 and 10. So 5, 6 is present in P where 7, 10. Here you see 7 is not present. So it will become 7 only. This 7 is not present in Q union R. No. The element of P 7 is not present in Q union R. Q union R. So that 7 will be the answer. Now Q union R will be what? Q is this set, R is this set. Combining these two without repeating. Q intersection is common in these two. Only 5 you can see, very obvious to you. Now P minus Q intersection R. Q intersection R is 5. This is the set. And P set is this. Which all are present here? P minus means 5 on leaving 5, 6, 7, 8, 6, 7, 8. I hope you understood. Go through once again if you need, then you will understand.